According to a nationwide survey, only 57% of rated capacity of equipment is delivered into the home. Combustion efficiency analysis is designed to increase that number. As an installing contractor, you want to be sure if you are installing a high efficiency furnace that all of the efficiency is being felt in the home. Combustion testing is the only proven way to ensure that fuel burning equipment is operating at its highest efficiency level. Combustion testing is becoming required in many areas of the country due to the increased emphasis on higher efficiency standards and safety of the households this equipment is installed in. Combustion testing increases the level of efficiency the equipment operates at, reduces costly callbacks, increases the safety of the equipment, and instills confidence in the homeowner that their heating system is operating to its highest efficiency level. Let's define some terms that are used in combustion analysis. Primary air is the combustion air mixed with the fuel as it goes through the burner. Secondary air is combustion air that is supplied to a burner flame externally to ensure that there is enough oxygen molecules available for complete combustion. Excess air is the amount of air being supplied to the combustion process above and beyond what is required for complete combustion. Dilution air is air that is not used in the combustion process. This air is added to the flue gas after the combustion process to assist with the flow out of the vent. Tramp air is air leakage through improperly sealed doors and gaskets and greatly reduces the energy efficiency of the appliance. Oxygen O2 is the molecule that mixes with fuel to burn. It is one of the supporters of combustion. Carbon dioxide, CO2, is a byproduct of complete combustion where two molecules of oxygen combine with one molecule of carbon. A high carbon dioxide reading is desired in a flue gas mixture. Carbon monoxide is a byproduct of incomplete combustion. One molecule of oxygen combines with one carbon molecule. Carbon monoxide is deadly and produces inefficient consumption of fuel. Flue gas temperature is the temperature of the flue gases exiting the appliance flue. And fuel efficiency is the relationship between the fuel being used in the combustion process and the heat delivered to the space by the appliance. Combustion is the reaction between a fuel, oxygen, and heat that causes the rapid oxidation of the fuel. Stored chemical energy in the form of BTUs, or heat energy, is converted into another type of energy. To achieve combustion, we need three components: fuel, oxygen, and heat. It's a balancing act. In your training, you may have seen a chart like this, which shows the flame characteristics of a burner. By increasing the gas rate or the gas pressure, we can become too rich in our setting. By decreasing the gas rate, we become too lean. By increasing primary air, we're going to get a hard flame and possibly a lifting flame off of the burner. By decreasing primary air, we're going to get a softer flame and a yellow tip flame and could see some flashback on the burners. So as I said, getting the right combination of air-fuel mixture for combustion, it's a balancing act. When taking combustion readings, you need to know what the numbers mean. Just like your gauges on the refrigeration side, you need to know what the high side and the low side readings mean in an operating system. So too with combustion readings, you need to know the relationship of the various gases that are contained in the combustion process. As oxygen and excess air increases, carbon dioxide will decrease. So any change in one will affect the other. Vice versa, as oxygen decreases and excess air decreases, your carbon dioxide level will increase. So again, any change in one condition will affect the other. There are different combustion categories. Stoichiometric or perfect combustion is the perfect fuel to air ratio where there is no excess air or carbon monoxide present. This can only be achieved in the laboratory. There is complete combustion, where the complete burning of all the fuel molecules with some excess air. This is what we want to achieve with combustion testing. And then there is incomplete combustion. This occurs when there is an improper mixture of fuel and air. This is extremely inefficient and leaves unburned heating value in the fuel. The causes of incomplete combustion may include inadequate supply of air, too much fuel being supplied, an inadequate mixing of the air and fuel, flame impingement on the burner, too much or too little draft, and lack of adequate flame temperature. Combustion testing is designed to reveal what the problem is and show how to achieve complete combustion and high efficiency. Usually when you purchase a combustion analyzer, you will get charts that will show you what the industry accepted values are for O2, stack temperature, draft, CO, and so forth. If you have not been trained in combustion analysis, this is necessary for you to know where the proper boundaries are for all of these readings to verify if a furnace is operating at its highest efficiency level. CO readings of 100 parts per million and climbing should be considered dangerous and should be investigated. The last thing that I would like to stress is that you must keep records. It is very important for your company and for yourself individually that if you're on a gas appliance and you're performing any maintenance or service or conducting a combustion analysis, you must keep records of the readings that you have taken. The old saying, if you touch it, you own it, apply to gas appliances. If anything were to happen after you leave a job site, your company and you personally would be held liable for anything that happens with that furnace and the household where that furnace is operating in. So make sure that you keep records and you do diligent work on the furnace to make sure that when you leave it, it is working in its highest efficiency possible, and you have done everything to ensure that that furnace is safe and operating correctly.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.